All right, welcome back to another exciting edition of Math with Mr. Howard. So I did this thing where I made a review guide and I made a group test, and I meant to give you the group test in class today, and then I was going to let you work on the review guide over the weekend, and then somehow I ended up printing out the review guide and giving it to you today, and then telling you that that was the group test. So the point is, what you did in class today was actually meant to be the review guide, and that's what's posted on Edline. So I'm going to post what I meant to give as the group test on Edline as well, so you get all of the practice that I intended you to have. All right, so that's just a quick update, but let's get through this problem now. So we have a nice rational function here. This one's going to be not so bad because we can factor this without using synthetic division. So we'll just make our little key features table to find some stuff. And before we factor, let's determine if it has a horizontal asymptote or not. So what we do is we go and we look at the degree of the function on top and on bottom. And it looks like it's the same on top and on bottom. That's the biggest exponent. So we know from our horizontal asymptote rule that in that case we're going to take the coefficients of the leading coefficients and make that fraction, and that's going to be our horizontal asymptote. So HA is at y equals -4. Okay, so then now we can factor it and find the other key features. Okay, so let's factor. So on top we have a -4, and that also goes into -16, and they both have an x. So we can factor out a -4x times x plus 4. On bottom we have a difference of squares that factors as x minus 4 times x plus 4. Okay. Next thing we do is we look for any common factors on top and on bottom. Looks like there's an x plus 4 on top and an x plus 4 on bottom, which tells us that we're going to have a whole at x equals -4. And actually what we should do is just say our whole is at -4 something. So we want to find out what the y value is. Okay. Looks like we have a vertical asymptote at x equals 4. And then we have a root. There's only one root, one x-intercept right here. Whatever makes -4x equal to 0, and we're lucky that's just x equals 0 because -4 times 0 is 0. So we have a root at x equals 0. And then we should also get our y-intercept. So let's see what we got. Our y-intercept, well, if we plug in 0 for x, we get 0 on top. We get 0 minus 16 on bottom, which means we have 0 over -16, which is just 0. And that makes sense. So our y-intercept is at 0, 0. Okay? And we got to find out what this y value of our whole is. So let's find it. We plug in -4 to our new function. We have -4 times -4 over -4 minus 4. Again, we're just plugging in -4 into our function x to get our y value. We get 16 over -8, which gives us -2. Okay, so we have a whole at -4, -2. All right, so we found all the key features that we can. So now let's actually sketch this using our key features. So sorry about this. I wish I should have zoomed out earlier. Okay, so here we go. We draw in our axes. Okay, let's draw in some lines here. Oh. Okay. All right, so first thing we do, let's draw in our asymptotes. We have a horizontal at -4, vertical at 4. So the vertical one at 4 comes down like this. Okay, and then the one at -4 is going to come across like this. Okay. really quick, let's make sure we understand this horizontal asymptote, -4. It's -4 over 1, so -4 divided by 1 is just -4. Okay, so there's an invisible 1 out here. Okay, so now let's sketch in our zeros. I think we had one at 0, 0. And then we have a hole at -2, or -4, -4, -2, right? Okay. So here we are at 1, 2, 3, 4, down, 1, 2. Okay, I think I can do better. Undo. Okay, here we go. There we go. All right, so we've sketched in all the information that we know. Now we know that our function is going to approach this asymptote, but it's going to come up, it's going to go through the hole, it's going to go through the intercept, and then it must go up like this. So we actually know how this looks on this side. So we know that it's going to be negative over here, and it's going to be positive up here. We've already figured that out. But what we have to do now is figure out what's going on over here. Okay? And it's actually, in this case, we don't actually have to, we wouldn't have to actually plug in a point here if we know more about functions, but all we know how to do is just plug in a point and see if it's positive or negative. So what we do is we say, let's just plug in +5 and see if it's going to be positive or negative. Okay. So we plug in +5. It's best to just plug it into this factored form down here. Okay. So if we do -4 times 5 over 5 minus 4, that gives us a negative divided by a positive, which is negative. So we know that this thing is going to be negative. And we also know that it must be below the horizontal asymptote, because if it were up here, well, the only place for it to go is across the x-axis like this. And since we know it doesn't cross the x-axis, we know it must be approaching the horizontal asymptote from right here. So actually, we didn't even really need to do that plugging in a point here. We could have just done our positivity, negativity analysis just using reasoning that, oh yeah, this function, if it were above the horizontal asymptote, it would cross over the x-axis, which we know it doesn't because we know that there's only one root. So we know that it's going to be negative down here. And then we're done now. We've done all of the analysis we can. So now we scroll down to the functions and we look for the correct one. And it turns out that function f, the graph, is the only one that matches our analysis. It has a root at 0. It goes negative, positive, and then it's below our horizontal asymptote at 4. So this one is graph f. And that's all we have to do.